Hello from your favorite artist, electronist Mr. Q12 here. Hello. Electronist Mr. Q12 here. Hello. So today, well, today I will present to you a very interesting circuit that I was after it for quite some time, for all my life. This is, there are things that you propose in your life to do, and you postpone them, and you say, yes, I will make them in the future. I will make them. And this was one of those dreams that I was trying to make, and I didn't have time. I didn't have the heart to do it, because this is a bit more abstract electronics. These are cousin circuits. This is low cousin, and this is high wattage cousin, and very low I will build next. This is actually a load tester, wattage or power load tester. It's a very, very good circuit. Actually, I had quite some good luck in a sense, because someone in the forums, electronic forums, from AAC forums, someone helped me with this circuit. I was hunting this circuit for a very long time. I knew about it, but I kind of forget it in time. For sure, I got over it when I was very young. Probably, I don't know how to say it, but this is not very new to me. But in the same time, I'm very happy that I started it, that I built it, and I actually got a very good result from everything that I built so far and tested so far, as you will see in a moment. So the idea right now is to present what I made so far, these two boards that you are seeing here, this number 1 and this number 2. And next step, I will show you how I'm making one of these boards, but for a very low value. So if this is 10, this is 100, I will make ones. From 1 to 1. You will see in a second what I'm referring. What all this project, all three of them will represent, at least for me, it will represent a wattage box. I'm calling it wattage box, but originally it's called a resistive loading box. I actually seen such a box, resistive load box. It was actually used in testing generators, big ass generators like 600 watts, 1200 watts. 3000 watts, so very, very big power loads boxes. And I've seen one of those. I remembered that I wanted this circuit to make for a very long time, actually, but I kind of forget the circuit itself, so I didn't know how to make it again. I put a lot of effort into it to actually get to this stage that you are seeing it right now, as simple as it is. For this circuit to actually work and mean something, I have to decide what is variable and what is fixed. And you have this problem for a wattage box. So you have 5 volts and 1 amp equal 5 watts, right? But the same wattage is equal, and it's true if I'm having 1 volt and 5 amps. Okay, it's also equal 5 watts. So you see, or intermediary 2 and 2.5, 2 volts here and 2.5 here, 2.5 amps here is also 5 watts. So you see, is quite an infinite ways of declaring a 5 watt box, like I'm doing it. So for this to work, I have to decide what is fixed and what is variable. And I'm deciding the entire project that is powered, I'm deciding it to be powered at 5 volts, but this amperage, it will be variable. So this is fixed here. So this is fixed. And this is variable. Only for this line here. Only for this. And this, I don't care. This, I don't care. This is the only true rule that I'm working with this circuit that I'm having here. So I'm having 5 volts all the time. That's what a fixed voltage means. I'm powering it with 5 volts. I'm not varying at all. This is the most important rule, detail. And I'm only varying the amperage. How I'm varying the amperage? Well, if you look on the circuit diagram here, this is how I'm varying the amperage. By switching all these resistors. You see, also here, I'm having a switch and a resistor. And this is exactly what I'm having here. I'm having 10 of these ones, 10 of these ones. I don't have a 9. I actually have 10, starting with 1 and finishing with 10, not from 0. So that's what I'm having here, pretty much. I'm powering this from 5 volts here on the top, which is a single long line. And the next pin, let me actually show you. You see, it's a jumper. It's having, let me actually zoom into it. Hopefully, it's having these 2 pins. Okay, it's a jumper with 2 pins and an empty space there between this jumper and another jumper. Let me put it back. Like that, and that's it. I'm connecting this point, the positive line, with this point that I'm having here on the resistor, right? Okay, and then the current is passing through this resistor. It is varied by the resistor itself, and this is the negative line. Well, not really, is because as you can see, it's passing in all of these circuits. This circuit and also this one is is passing through this 1 ohm resistor to the ground, and also here 1 ohm resistor to the ground, and is exactly what I'm having here. Is passing through this resistor 1 ohm. You can see it here, 1 ohm, 5 watts, and this is the actual ground. I'm having this other wire here, this blue wire and this red wire here and here connected basically over this 1 ohm resistor. This voltmeter that is set to millivolts, and this is my voltmeter here that is set to millivolts. Actually, let me show you. This 2 volts is actually 2000 millivolts. Here it means 2 volts, but to measure over this resistor here. But I will not get to that 2 volts. I will get only to 1 volt, the maximum. And that 1 volt, it will translate in amperage actually, and it will be the maximum for this when I'm having all these jumpers activated, and I will have 1 volt here on this over this resistor, and it will represent 1 amp, and then lower and lower 100 milliamps, less down to here, which is 100 is 100 millivolts or milliamps steps. What I'm having here, 10 steps at 10 milliamps per step. Okay, and this this voltmeter is measuring over this resistor the voltage, which it translates, it converts, it represents actually the amperage that is, as you can see here, this millivoltage is actually amperage. Is the same with this one. Okay, this is I'm saying there 1 milliamps, but this is the next circuit that I will make. For now I'm having 10 milliamps and 100 milliamps steps between each. I didn't say for what is this for, but it will become more clearly in the next episodes, and as I promised, I will test some stuff with them. But for now, for the moment, I'm testing them to be at a certain parameter and not to burst in fire. Especially this one. This one is not a problem, but this one it was a problem. What I'm having here, let me also show you, because these are very interesting resistors that I'm having here. As you can see, I made these cardboards, and I put all these resistors on these cardboards nicely, in this fashion, like you are seeing it here. This is my invention actually. When somebody gave them to me for free, and they were in bags. They were all together, you know. No, they were not in order, and I had to test everything, to measure everything, and to make them nice. And for this project, I'm having already 51 ohms per each resistor that you're seeing here. So in total, I had 13. You see, I'm left with 3 others. So I was very, very lucky to find this value between all my resistors that I'm having. Let me actually present them to you. Ta-da! I'm having this. I'm having this. These are actually boxes. This metal box, I believe it was sugar in it. It was a very expensive sugar from very old times. I believe you didn't buy them, these boxes. You didn't buy them by themselves like this. It was an element there inside them, and that person, he is an old dude, and he gave me a few years back. I have them for a very long time. So let me show you what's inside them, and it's very military, because probably that guy was in army, and as you can already see, they look with that green paint on them. So this is one, and it's full. I will not take them out, but believe me, I will take 1 or 2 just to show you. So this is how and I have very, very long, like this long, very, very long, that I put it there, and I bend it underneath, and yeah, and I also put the note on each this string of resistors. As you can see, this is normal cardboard that I collected from somewhere. I bend these legs of these resistors around it, and it's very solid, very stable, and it's good enough. And all this guys here is 10 mega because I measured them, but it's also saying there 10 MC, and that M represents mega. These are Russian resistors, power resistors, and they are not that powerful actually. You see that one BT? Let's see. Let me actually zoom in. You see that one BT? It means in Russian V. That B, it means V, and T is T, and it means 1 watt. Watt with V, not with W. You know, and yeah, that's the Russian, and you can clearly see the winding. Yeah, you see here, I'm having this nichrome wire. This is resistive wire that you use for a heater, you know. But this is what I collected, and also I have brand new this roll here, and this other roll is brand new. And this is nichrome wire. This is the diameter of the wire, 0.16, and this is 0.3, which is double than that. And I have also 0.5 there as well. So very thick nichrome wire. You see, and this is the wire that they used here. I wanted to show you. There's nothing special about this wire. The only special thing is that is having a certain resistance to it, and is getting red hot when it's overheated. But if it's used normally, and I believe it's also lowering in resistance when it's overheating, when it's red hot, and then it will break like a filament, like a bulb filament, like the old light bulbs with a filament inside. I know because I had a heater like that made in home with that kind of wire. We were very poor in other times, and we had to make one of those. And I know some wire like that was burning out, was melting, and we had to buy more wire to make it more resistive. And that's how I know. And I know for sure these are resistive, is having these resistive wires inside them, because I can see that. I can see it, the channels at least. So that's it about these resistors that I'm having here, and the same is here as well, as you can see, but other values of course, very different values and very unpopular values. I'm having these 3 boxes full of very all of them is 1 watt resistors, and very different values, very different from all the categories, but very unpopular. Very unpopular. The thing, I don't have 10k 10 kilo, I don't have 1 kilo, I don't have 100 ohms, not even 1 ohm resistors like this, or 2 kilo 200, I believe. Also I don't have them. I have very unused very unused values. Probably this is a remaining of resistors they wanted to throw away probably, and this guy collected them and said, give them to me, I will use them. And he stole them very long time ago in the communism period, when everything was made for the people. You know, in those times, not like today when everything is made only for money. So that's the story of these resistors. Let me put them back down next to my leg here. So yeah, this is the story of this 1 watt resistors. Exactly 1 watt is actually saying there is the same resistor like this. So you can see them, it mentioned there 1 BT, it means 1 watt, and 51, and this AE, that's an E, I don't know what it represents, but I measured them actually, every resistor, each resistor I measured. I know for sure what the values they are. So I catalog them pretty much to know exactly what I'm having, and it come very easy right now to find them when I'm having these labels on them, and this way of storing them. Okay, enough about these resistors, because it's not about them per se, but it is an important detail. I will mention this now, and probably I will mention this detail later, that this 1 watt resistor is not good enough, what I'm having and what I'm using here, because it's heating up. As you can see, here is a note to myself, and for you, why not? The maximum that of the temperature that I collected in a period of 5 minutes of testing this entire thing was around 80 degrees Celsius. This was the maximum, and it was on 1 blue resistor that you can see it there, because that's 250 milliwatts power resistor, and that resistor is a correcting resistor value that I'm putting here, because if I'm letting this 51 by itself, the measured the wattage and the measured amperage that I'm getting with my ampere meter there, with my voltmeter actually here, is getting lower and lower. And this helping resistor that I'm having here, this blue one, is helping to rise up to the value that I want, you know, to be as perfect as possible and good enough as possible, you know, not to be too much off, because the value are shifting. So this 80 degrees Celsius is on one of those very weak resistor values. Here is very low value, is like 100 ohms or something like that, 120, that one. And there is one exact, you can see it like a yellowish one underneath this green one. You can see there is, that is a bigger wattage than this one. Probably that's 500 milliwatts resistor, but these are a quarter watt, 250 milliwatts, these blue ones. And this is the smallest value that I had to put it there to correct the overall reading that I'm getting there. These are correction resistors, you know. And from here, from start, this is 100 millivolts here with this resistor here, and I'm having here something like 3 kilo, the correcting resistor that is under there somewhere. You can, yeah, there it is. So that's the correcting resistor there, and that's about 3 kilo. It's very large, and then it's going down. This is 2 kilo, 2 point something kilo probably, and less and less and less and less, down to 100 ohms, that one. And this one is actually, you see, 62 ohms, this last one, in parallel with this 51, to have an exactly 1 amp here, because only with this 51 that I'm having here, it was 930, and with this in parallel, this larger one is also a correcting resistor for the final reading. The usual, or the normal, let's get back to the original idea that I was starting with. The usual temperature is about 50 degrees Celsius in general over these big resistors, these green resistors that I'm having here. Kind of, relatively. Some are 55, some are 60, but in general they are about 50 degrees Celsius. There are hot spots, there are cold areas. on the same resistor, like you are seeing, especially here in the middle and towards the endings is colder, and fixing the middle of it is getting extremely hot. And also for the entire batch, these guys in the margins are colder, and towards the middle here is hotter. It's kind of what I observed so far from my tests that I did already, and I'm telling you what I observed. These are my observations, and it's a bit weird. It's a bit weird because at 1 watt per resistor it should have been 250 milliwatts per resistor, but is exceeding the wattage, at least here in this setup that I'm having. I already put a command on AliExpress to buy more powerful resistors at bigger wattage at 5 watts per resistor, and also exactly this 51 ohms resistor values, but at 5 watts instead of 1 watt that I'm having it here. It will come in probably 1 month from now, because today I put the command for it, because today I finished this, and but it is working as it is. But it is heating up a little bit too much to the 80 degrees for some special resistors. But 50 and 60, probably some of them are 60 actually. But the large majority is 50 degrees Celsius. All right. So you understood the idea that I explained so far. And with the temperature, because I did really get the temperature with my funky probe there. And I was staying with my eyes all the time. And paying attention all the time to the temperature dissipated by all the resistors, to the hottest resistors, because I was literally staying like this. I was putting my hand like this and feeling them, how hot they are getting. Like I said, these green ones are about 50 degrees, and special ones are getting up to even 80 degrees. But it's not, this 80 degrees is not for everybody. It's only hot spots, and those that are getting to 80 degrees Celsius probably will scorched themselves. With time, they will start to get weaker and weaker. Most probably, I'm expecting it to be like that. And even these ones that are at 50 degrees Celsius, this nichrome wire, probably they will start to get down in value with time, with usage. But most probably this is, I'm not sure how temporary it is, because I will get those better 5 watts resistors, and probably I will remake all this board that I'm having here. But until then, and until they will arrive, I will use it. Another point is that usually everything should run cold. Nothing should run hot or even warm. Let's say 50 degrees Celsius is warm, but for me it is still hot for any components. So it will degrade thermically and electrically. It will degrade as long as I will keep them operational. But for short operational tests that I will do with it, it will be okay for a very long time, because to get to this 50 degrees Celsius, it takes times like 2 or 3 minutes. If I'm less than 2 or 3 minutes, then I will kind of protect a little bit better. But I'm not about protecting this circuit. I want to get hot, because a little bit hot to its nominal temperature, the usual, that 50 degrees Celsius. I want it to be at that, because if it's cold like it is right now, it will boot up with lower values. You will see it when I will test it, and I will show you. But when it will reach 50 degrees Celsius, it will get to the nominal programmed values that I originally set these resistors, and with its helping resistor, that blue one, for each, the value it will get exactly how I programmed each of it at this 50 degrees Celsius, because this is how I was operating it at this temperature most of the time. It was in power, and I was soldering the resistors and testing them, and checking them. And for checking everything to get the values that I wanted, they got hot and they stayed hot at this temperature. All right, so that's it with the talking. Let me actually exemplify it. Here is my power supply that is 5 volts, and let me open it. Ta-da. And that's 1 amp, 0.98. But look what this guy is showing here. Exactly 1 volt. It's 1000 milliamps. You see here, this is 2000. So this is 2000 milliamps, and we are exactly at its half at 1000. But exactly 1000. And this tiny little bit of tolerance that I'm having here is because I use this correcting resistors, especially this one in the margin here, and those blue ones that you've seen there. Let me actually reset it, or get down to 100 milli. 7, 6, 5, 4. If you follow these blue jumpers, you'll see exactly those numbers there, 3, 2, and 1. And right now, and if I'm taking it out, nothing works. Okay, it's completely off. And if I'm initializing it here, is exactly 100, and a tiny little bit of tolerance there, because I use those blue resistors underneath each of it. This is what that correcting resistor is doing, is adding this tiny little bit of tolerance to be a little bit up, not to be 99.5, because I hate it. I literally hate it. I like it when I'm seeing the entire number here, what it represents. This, if this is 100 milliohms, 101 is better than 99. In my book, this is how I like it. Everybody is having its own little details to operate with, and this is my detail. This is how I like it. All right. So the next jumper here. So now I will increasing the current, testing the voltage with this voltmeter, and actually this is translating into amperage. So here is 200 milliamps, and look what my actual ammeter is showing exactly 0.2 amps or 200 milliamps. Okay, so it's exactly in accordance with that as well. Not perfect with that one, but for the big majority of the settings that I'm having it here, it's good enough. So here is 300 millivolts, and that's 300 milliamps there. The voltage stays the same, is the same 5 volts. Okay, like I said already, this is the rule. A fixed voltage 5 volts, but the amperage is varying, and I'm varying the wattage when I'm varying the amperage. So this is 300. As you can see, this little tolerance that I wanted it a little bit higher, but not too high, around 3, 2, 3, 4 maybe. Here is a little bit too high. Like I said, I have to wait to heat up everything to 50 degrees Celsius. If I'm leaving it to warm up, it will get exactly to the programmed voltage that when I use those correcting resistors there. All right, I hope it's clear. Okay, so I'm having 4 jumpers. I'm having 400 millivolts there, which represents 400 milliamps, which represents now the wattage. What it means this: 5 volts times 0.4 equal 2. This is 2 watts, what I'm having right now at this point. And let's continue. This is 5. As you can see, a tiny little bit of tolerance over the value. Not to guess, yeah, it's 499, 497. Bullshit. I wanted to see that 500, you know. And next value, 600. And also let me show you this is actually showing me a little bit less. Why? I don't know why. So it's not exactly in accordance with this voltmeter, but it's good enough. I'm actually using this voltmeter to read this value here, and the less that I will use it for other objectives. After the entire circuit it will be finished, you will see in time what I'm planning with that and what is useful for. For the moment, it is confirming this voltage that I'm having over this resistor here. Okay, so now let's jump to 700. As you can see, already we were talking here, and this is already heating up, but these are cold here, of course, but these are very hot here. And they will get very hot. They will become more and more hotter as long as I'm adding more jumpers to the last one. That's the rule. And they will get colder as long as I will take out the jumpers. So this is 900. And as you can see, I'm a little bit over just to see that 900. Okay. And voila. This is a little bit too much over because this is cold. This last one is cold, but when it will get warm, it will get down to 0.5, something like that. And also, there it is, 0.99. So right now, let's calculate this. 1 ampere times 5 volts is 5 watts, pretty much. What I'm getting through this, on this 2 wire that I'm sucking. This circuit is sucking 5 watts and is consuming 5 watts, this entire circuit here. And these wires are delivering those 5 watts. And they are cold, they are not warm. And also the alligators are cold. But these are quite hot here. And let me actually show you the temperature, because this is the only circuit that requires close attention over the temperature. Okay. So the ambient in my room right now is 27. Actually, it was 25 and this motherfucker didn't want it to go down at all. Huh. Well, it's not that well programmed then. Or only now when I'm making the movie is doing that. But I swear, it was 06 for a very long time, actually. Okay, so here is very cold. It's about 30. 35, 6, yeah, 36. But the problem is that I'm moving the sensor here. This is the sensor is a blob. Is a tiny blob there, and that's the actual sensor. And if I'm moving it around, it will read different values. This is very hot here. 50, exactly 50, well, 52. Actually, if I remember right, here on the top, is getting to around 60. 57, 8, 9, 60. I'm not actually proud, and I don't want it to overheat like this, but it's the best that I could do so far. So I need a little bit bigger wattage resistors than what I used here already. I actually have a better 1 ohm resistor at 10 watts than this one, which is at 5 watts. And what I'm having here, exactly 5 watts that is consuming here, exactly 5 watts is over this specific resistor, this 1 ohm resistor. So I'm using it at its maximum potential, at its maximum value, and it's 63 degrees, more or less, around 60, like I said. Okay, let's continue with, let me cool down the probe. So let's check like I said, here, somewhere in the middle, here is the hottest zone. So I'm measuring this guy here. And I'm getting 50, well, it's not that 50, it's also 60, no. Yeah. But if I'm using exactly 60, but if I'm using less jumpers here or less wattage consumed, it will get to that normal 50, to this normal 50 here, usual 50. But it must be less power than this maximum. Right now we are testing the maximum of what this resistor bank that I built here can deliver. The maximum consume of this circuit. So let's put it again. So like I said, 60, it was exactly 60 here. Well, 63. And now if I'm moving the probe a little bit, it will vary. At least it was varying when I tested it. I'm not sure now. Yeah, you see, now it's 60, and if I'm moving it here, 63, and if I'm moving it a little bit more here is 64. Okay, and here 62. So it's not perfect on the length of the resistor. It's not the same value, which is a bit, you have to understand and be patient with these things. And let me test and measure this resistor, this programming resistor or correcting resistor that I put here. And you will see it at hopefully at 80, like I did my test the last time. 70, there it is. I have to hit the sweet spot where is the hottest, pretty much. So 76, 77. Yeah, I don't remember if I actually got 80. It was around here at 78, 79, like that. But I rounded it as an 80. That's the value that I got the original time. Yeah, 79. And it's rising very slowly, probably. Okay, like I said already, this in the margins are cooler, especially this one. Yeah, I see 51, and this one here next to it is 58. It's dancing around 58. Okay, let's see. But these two have bigger wattage correcting resistors there. This is having 3 kilo here correcting resistors. So this should take a lot of heat blow over it as well. Let me put it like that. No, not really. 53, 54, 55. Slowly. Yeah, 56 something. Okay, the second one here. Yeah, this is starting to get more warmer, more hotter. This is closer to the ones in the middle, but the ones in the middle are the very hot ones. A couple of them, not only one. This, like that, and probably this 4 or 5 even. You know, they gather the heat towards the center there. Okay, this is it for this experiment. As you can see, it is delivering exactly 5 watts. The maximum, this one. Oh, let me take the temperature of this one because this is very hot here, at least for my fingers. The last time was 60, the same as this one's 60-ish. And I am actually happy with this temperature. It's good that it didn't go to 100 degrees. I'm very pleased with 60 degrees. It's okay, but it can be run more cold than this value, heat dissipation that we are seeing here. All right, okay, let me close the experiment, at least this one, this more powerful one. So these are 100 milliamps or millivolts steps, what I'm having here. These are 10 millivolts steps. And I will have to take these wires from here, disconnected from this module, put aside and connect this module here on those, okay? One moment, please. All right, this is actually the first circuit that I made. And then today I made this. This I made it yesterday, no, 3 days ago. And yesterday and today I built this one. This one, I wasn't very sure how these resistors will behave, and I had to search for them and to fit everything, and I wasn't sure if I have 51 ohms resistors, but it looks like I do have. This is on cardboard, by the way. This is a piece of cardboard that I built all this, and I glue it over this thicker cardboard that you're seeing here, and here I put this very thick rail, and I soldered the resistor over there. This was a special one, that's why I left it the second circuit to build. So like I said, this was the actual first one, and right now when I'm putting my hand here over all of these resistors to check the temperature, this is how I'm checking the temperature with this side here, because this side of my finger, the skin is very thick, and I have to wait too much time to actually sense the actual temperature for a very low temperature, like 30 or 35 degrees Celsius. Let me put my thermometer here. So this is again full 100 milliohms and is 10 by 10 steps. So the ambient right now in my room is 27.3. Let's see. I'm not even sure who is the hottest here. Probably here. Yeah, it's mild, a little bit mild, warm. This is warm. I'm getting a warm temperature here. It's not hot at all. Somewhere at 40 degrees, 45 maybe degrees. That's what I call hot. starting to get hot at least. But at 35 degrees, like you're seeing there, is if I'm lucky to catch it again, it's warm. This is a warm, fuzzy, warm, very fuzzy, warm temperature. Again, this is when everything is connected, when it's at full capacity, what I'm having here. But if it's lower, if I'm lowering the capacity, it will significantly lower the temperature. So I check it right now for temperature at full capacity. Let's go down right now. Let's do like this from 2 by 2. Okay. And as you can see, here is on the money exactly, but this is not how I measured this. I measured it even lower here at 200 milli, here at 200. So I switch it from 2000 that I used for this, and now I'm using 200 millivolts, and this is how I'm reading the other tolerance decimal that I'm having there. These are 510 ohms. So here for this project I use 51 ohms, and here is 510 ohms. So this is 10, and also voila, there is also 10. This is 0.01. That's 10 milliamps, and here millivolts, because it's across this resistor, 1 ohm resistor. So the next one is 20.5, 0.6. I wished it was 0.3, and I did get this 0.3 value, 3, 2, 3, 4, like that. That's the tolerance that I was hunting for. But it is fine as it is, as you are seeing it right now. Probably you can observe, let me point, you can observe this is 5% tolerance, this is 1% tolerance. So as you can observe, I'm using this 5% here. 4 of them are 1% tolerance, and this 5% again here, and then 1% tolerance here. Because this is how I calibrated, I kind of balanced this tolerance that I'm having there with the help of this 5% resistors. If I was using only 1%, it was decreasing, the tolerance was getting down too much. But adding this guy here and here, it kind of balanced everything. This is almost 41 here. This is not good. But I swear to God, it was very low. Well, okay, so this is 40, and there is showing also 004, which is good. I will probably have to calibrate them even better than it is right now to get to that 0.4, because now it's very close to 51 there instead of 50. Yeah, this is 61. Shit. This is 71, or this is good enough as it is, probably. 81, unfortunately. 91, and 100 and something. 10 millivolts stepping for this circuit. You can also see here this resistor and this one here, correcting resistor here in parallel here. Or this resistor here is starting to get weaker because I weaken it with this power setup that I'm having it here. Probably it's weakened electrically from that test there. Who knows? And now in this circuit that I'm having here, it is showing me a tiny little bit of difference there that I know for sure I wasn't getting it like this, like it is right now. Very strange, very strange. I am usually quite exact and quite precise when I'm doing stuff, and I'm very upset when I'm not getting what I programmed initially. Yeah, anyway. Also, right now is 100 millivolts there, and also that's the amperage is showing 100 milliamps. And this 5 volts times 0.1, so 5 times 0.1 equal 500 milliwatts, half of a watt is what I'm having here, dissipated by this entire circuit. Again, this was the actual first circuit that I built, and as you can see, there are some mistakes here compared with this one, because here I put in individual pads for each leg for these jumpers, while here I got smarter than this, and it's a lot of work to do it like that. And also here, and I put one single line and also one single line here. So this is better design than this one. This was the first one, and I wasn't sure how it should be, like how practical it should be. So I made it as practical as I could think of using these small pads, but I didn't have to. Yeah, this is a little bit of mistake, a designing mistake on the first try. But on the second try here, this is way more better design-wise than this one. So I learned. And the next one with 1 milliamps, I will also add. I will make it in this form with a strip, long strip here, and only individual pads here. That's it. Okay. Okay. Fine. From here, these pieces are from here. I took one of this and smash it and make it flat, and this is the pieces from this. You see, I'm doing it by the eye, not recommended, but faster, a little bit faster. This is the easy way, by the way, what I'm doing right now. There is a hard way when you already have them cut and you have to fit them there. That's the hard way. That I'm always doing it actually. It's in my second nature to fit what is already cut and already used, you know. But this is more fun and more easy to do like this. So 1, 2, 3, 4. Da, 4. 5. This is a little hard to cut. Fortunately. Oh, 5. I only did 10 of them. And 5 is enough. There is a bad side and a good side, and this is the good side where it's more shiny, and this is a little bit more matte, you see, and that matte side is not good, the shiny side is good. So I'm paying attention to that little detail because it's important for the solder to catch correctly and properly, otherwise it will peel off, it will fly away. So right now I'm having 10 for this, yeah? All right, very easy, right? Very easy. But now take a break. All right. I noticed a mistake that I made. I wrote here 100, 200, 300, 500 milliwatts, but these values are actually wrong. This is what I really wanted to have per each branch. This was the idea that I wanted to put it in reality, but what I'm having here in reality are completely different numbers here, up to 1 watt, because 5 volts, which is constant, times 0.5 when I'm measuring here is 2.5 watts. So I'm going up to 5 watts actually, while this line here is going up to 1 watt. So here instead of milliwatts should have been voltage or ampere over this resistor here, because that's what these values are showing actually, the measured value over this resistor. So here should be voltage, not watts. Let me actually correct it, but right now I'm in the future, so there is my correction, millivolts, and is over this resistor here. I'm making a little arrow there. So make abstraction of this little detail in the movie, because I catch it a little bit too late, unfortunately. I was thinking on something, but I wrote something else, and I didn't stay and compare it. I didn't catch it on time. That's it. But I did after a while, after looking a little bit more with more attention on what I wrote there. Yeah, shit happens. Mistakes are happening, and let me make a bigger arrow here. That mistakes are happening, and the rule of the game is to correct them, to catch them, to correct them. Voila, I deliberately leave more or less spaces. I didn't make them all equal for you to see that it doesn't matter how equal they are in this particular case, because it's only two connections per pad. One connection is from this jumper, one jumper to the pad, and the second connection will be from the resistor, and that's it. And doesn't really matter how long or how exact everything is. It is a trivial matter. I apply the same mentality everywhere. If you are paying close attention, nothing is really equal. You see this, how short it is, this one here, but in the big picture, it doesn't, you don't see it anymore, you know, especially here. Yeah, so now the next step is to solder this, actually prepare it, and then solder it here, and this module will be done. Okay, let's do it. This band, long band that I'm using here, is for a spray, and it is perfumed. The perfume in that bottle, spray bottle, got into the metal, if you can believe it. And now when it is overheated, a couple of molecules there got catched probably, and it's smelling very, very nice, very, very cool. It's better to take this kind of material from deodorant sprays and not from insecticide spray, because when you are heating it up like I am right now, it will smell as insecticide instead of very nice, pleasant, deodorant smell like I am smelling right now. So that's it's a little detail trick you should be aware of. But if you cannot find anything else than insecticide bottle spray, then use it. But it's your nose. It's your nose. I actually had this experience. I had, and probably I still have some insecticide steel metal from. I know exactly what I'm saying, because I did make this mistake in my life, and I have the experience with it. And I'm telling you, it's not nice. It's better to avoid it, is what I'm saying. And it's very easy to avoid it, actually, if you are thinking a little bit, if you are planning. As you can see, some pins are higher than other, but my jumpers that I'm having here, these specific ones, these are not scrapped, these are brand new actually, and I rarely use them. I rarely find a use for them. And as you can see, they have a hole here on the you see, this is the entry point, but on this other side it's also having a hole here and here, and it's permitting the longer pins to stick out, if it's the case. But it's not the case, so it flashed with that longer pin as well. So it's really, it doesn't matter. And also here you see this is longer than this, and if I'm putting this, it will be fine. Yeah. See, excellent. All right, and this is very, very sturdy, very secure, very strong. It is a strong bond, especially from pushing and from pulling. You see, when I'm dragging, it will not crack from the pins there. It's very strong, like this. And before I forget, this piece, if you pay attention, especially here, you see it's made, you see here, it's made, you can see my finger between them. This is a piece here, and this is another piece, and the same goes for this one as well, but it's not that clear because I actually left one here, one black one, but there, or here it is, and is it there? Let me point with this needle here. So I'm having this element and then this element for which I left this little one. This is the only one that I made it full, from a full bar, not cut, not from parts. like the other ones. All right. Okay. It is a little bit of work, and it took me like one per day. This I made it in one day. This one I made it in 2 days because I had to pay extra attention to the heating and power element, and I also had to search for these resistors, specific resistors that I wasn't sure I'm having them, but I was quite lucky to have them. So this one took me 2 days, and this one I started it today and is already half done. So this is one half and this is the other half pretty much. I'm also taking breaks, so this is advisable, very advisable. Work with breaks. And right now, after I soldered everything here, I will take a break, short break, like half an hour or 1 hour break, watch some movies, play some games, stay on Facebook. And after that I will come back and I will continue the thing with a little bit more fresher energy, because this is depleting your energy. This kind of work is consuming your energy and your concentration, and you start to get bored, you know, and you have to be a little bit more activated. Also drink an energy drink is very good for this kind of exercise. But I am rarely drinking energy drinks because I don't have the money. It's that simple. This kind of work is not paying anything. It's just for my pleasure and my because I want to make them. Basically, it's not. This is not a paid work, and I never worked, and I didn't find any kind of job that will pay me for such prototypes that I'm literally enjoying making them with breaks. All right, see, like it never happened there. Perfect, absolutely perfect. Love it. Das ist ein excellent solution. And now the hard part is to fit and measure everything. But before I will do that, I'll have to put this band like I put it here. This is a long metallic strip that is also catching solder very well on it. It's treated. It is nickeled, and this nickel is catching the solder very well. Actually, let's make a test first. Oh, yeah, I shouldn't have made it this long, because it should be like this long. Actually, this I had this longer resistors, but here I will use these smaller ones. Yep, I said I'll make a test. Well, from what I remember, I think, yeah, it's catching very well, very nice. Okay. And here, to get 1 millivolt, I'll use exactly this circuit, or 1 milliampere, 5.1 kilo. There, this one. And now, let's make the test. I'm always making the test. Hopefully this will. Huh. High hopes, huh? What? It should have. Because I don't have the the jumper. Actually, I should mount the jumper. Yeah, but that one is not having another zero there. so right now I'm at 200 millivolts, and this is the voltage that is measuring here, and is 1 millivolt, exactly 1 millivolt. Okay, and let me actually put everything here. But I want it a little bit higher to actually read 2 point something, and I will have to add. Let me actually put even less to be 2 point, between 1 and 2, the tolerance. So I will lower it even more than this. So right now I changed my mind. Yeah, it's a stable 2.1. Okay, it's more stable right now. It's probably near 2.2 somewhere. Okay, so what this thing is doing, this correcting resistor, this 33 kilo, it is adding a little bit, it's like a drop of current through it. So the bulk of the current is passing through this 5 kilo, 5.1 kilo. Where are you? I put it back. So this 5 kilo is letting the majority of the current flow through it, like here, and this correcting resistor is letting a little drop of current just to equilibrate here. I think you get it already. It's not that hard philosophy. 3.1, between 0 and 3.1, which is very okay. All right. Right now, this is how I'm setting the thing. But later, when I will make the entire circuit with all these working modules on a single circuit, then I will decide if I will leave it as it is right now with 3.1, this decimal, or to be lower and then tweak it from the other two, the lower ones. If I need 0.1, I will tweak it from 1 millivolts from here. If I need a little bit more here when I'm tweaking the tens, so I will probably change every resistor a little bit lower to tweak it from the lower modules, this higher module that I need. But this was an idea that it traveled with me the entire project, this entire project, and I was very, very uncertain if to leave it like this, because it's very readable like this. You can clearly see it's 3. There is not 2.9 or 2.99 or 95 is a little bit well, it's not nice. It's nicer when you see the actual limit that you are making everything. And this was a decision that I took it. I said, well, I want it like this. But later in the final circuit, when I will actually use it and test it more thoroughly, when I will actually work with the entire circuit, if I will decide to lower everything, then it will be another step for this circuit, so to correct it even more than it is right now. So I will have to change absolutely everything. So I know about it, but so far I'm working with as it is, with the decision that I took originally. So that's you can do whatever you want with your projects. You are free to really do whatever you want. But I had to make a decision and stick with it. Yep, good, very good. 0.2, 0.3 is very good for me. If it's very close to 0, it will switch to 3.9. If it's very close to 0 or 1 even, but right now it's very good. Let's see, 2.2, 2.1, 1. Yeah, this I don't like it when it's exactly 1, because it can go lower a little bit to 0.9, but so far is good enough. I mean, I don't see a noticeable changing. Yeah, it's good. It's good. I like it. I can make it very precise, 4.0, exactly 4.0, but I don't want. I leave a little bit of tolerance, and in this case, I leave a higher tolerance. This is quite easy actually right now when I'm constructing it, when you are seeing it right now. But usually I had a little bit more problem there and there to those other ones. Right now it's just working like a charm, and with the tolerance that I want. This is scrapped. Motherfucker. It just broke. What a shame. Well, so these are scrapped solder. This is scrapped solder with some impurities in it even, but from boards, miscellaneous boards. And this is how I'm using it, and it's very practical. I cut it to pieces, to small pieces to fit that little box that just broke in front of your eyes. It shouldn't have, but it did, motherfucker. Maybe I should change it to 0.1. Now I'm thinking, let me change this to 0.1. Yeah, see, 4.9. Not nice. Not nice at all. I don't like it. Yeah, see? 0.9. Not nice. So this is 33. Let me lower it a tiny little bit. Not to be that too. 33. So I'll put this 51 kilo again. Yeah, I love these resistors. They are very, very good. These brown resistors are brown grayish resistors. They are excellent. Excellent here near the how they are catched. They are not breaking very easily. They are very solid made. Excellent brand. Who made it? I don't know, but I only have the scrapped ones, and they are very, very good. The best that I could find. One of the best. These are good also, and the 5% as well. Let's see. Oh, yeah, good, perfect. This is looking like a diode here with that blue marker. But I'm telling you, it is a resistor. Very good one, actually. So this is adding a tiny little bit. 5, yeah, well, 3 is still on 0. Because this is hot, probably. Should be 1 there. That was the intention, at least. Shit. To leave it like this? What do you think? Unfortunately, I don't have a even... Yeah, good. So now it cooled off. Should change to 1. Yeah, a little bit. Good. So it's very close to the 1. This one is actually over 1. It should flicker. Yeah, 4.1, good. 5.1, good. 6.1, very good. Good. So this is even 2. So this, yeah, it's good. I can see it's increasing a little bit, but it's fine. Okay, it's okay. 0.3 is good enough. It should have been nice to have them at 1, all of them. Good, it's stabilized. Oh, good, it's going down now. Or probably because this is hot. Yeah, well, we will see in a couple of minutes how it will actually stabilize. It was quite a challenge to calibrate this one. For each of it, I put a correction resistor, and here only partially, a little bit. But depends what you want, you know. You can leave them without that this correction resistor. But it's good to know about it, and it's good to apply it. And yes, this is another decision that I made to actually go from 1 to 10, not to 9 right now, as it is right now. I could have stopped at 9, but I said, well, it's probably nicer with 10 steps. Well, it would have been nice to be 10.1, but 10.3 is good also. Let's see. Yeah, I'm looking there on my here, on my power supply, and is also 1 there, which it means 10. milliamps there, and here is millivolts. Okay, excellent, excellent. I like it, I like it. And this is it, I believe. Yeah, looks like this is it. Until here, I should cut it. Let me actually cut it while it is functioning, actually. And probably I will cut it even more, a tiny little bit from here, because this is, I don't need it, that part. Okay. Should I do it now? Yeah, I can do it now, actually. Okay. I'm committed to it. And nothing is burned, everything is still working, and it's also cut to length. Yeah. So this will be the entire module like this. The entire device, actually, like this it will be, of course, linked together, and and also a bucket or a little box for these jumpers to put them in that box. I'm thinking, but we will see if I will actually add a box for the jumpers, not to lose them, you know. And I'm recycling these little things. They are very practical, very useful in future projects as little links. Yes, yeah. Pretty cool, pretty cool. I like it, I like it. I hope you liked how I'm building stuff, and how you've seen how easy it is to make it with a little bit of patience. Now I'm checking if everything is hot, what is not. It shouldn't be hot at all, or warm. It's not even warm, it's ambient temperature right now. And also this one. Yeah, now that's it for this part and for this circuit. It's finished. It's that simple. It's a couple of resistors with a jumper or a switch, and that's it. All right, thank you very much for watching, and see you later when I will actually build the entire device, and hopefully I will film it. But I'm not I'm not promising anything, because I will have to think about when you know, when I'm filming I'm a little bit distracted, and now I made this module here a bit automatic, because I already had this two made and I knew exactly what to do. The next step in this project is to actually concentrate a little bit more serious, not to be distracted by the filming and by the presentation movie that I'm creating here. All right, that's it. All right, so this is my setup that I'm having here. I already tested everything that I'm having here, the entire project pretty much. And it's not quite as I imagined, but well, it's good enough, I suppose. Next, I wanted some switches between these two modules to activate or deactivate them very easily. And pretty much I'm cutting either the negative line or the positive line to that and to this. And I wanted to show you how I made the switches, the switch support. So this is the switch pretty much, and I melted some plastic, and this is cardboard. It's the same cardboard as this one here. You see it's having some black thing, and here on this side is also black here, but on this other side is the same color as this, and because it's from the same cardboard. And the plastic is like wax when it's liquid, when it's hot and liquid, and is adhering very good to quite a lot of surfaces, especially to cardboard. Is entering in the skin and the pores of the paper there, and is adhering, even if it's painted like that. I don't know how to explain it, but it is how I'm saying. It's a very good adhering process, especially when it's hot and liquid like that, and it's creating a very good bond, very strong bond. And pretty much I build it up from here, from this side, and going, actually I holded it like this up, and I was building it up until I reach this pin level, the maximum pin level there, on both sides, and then I turn it and prompt it to the cardboard and added a little bit on the sides, and that's it. And also here on the top I should have used some screws, but melted plastic is way more easy to work with, and is working. It is switching, not having any problems, because I did have a little bit of problems. I got a little bit. I was keeping it like this in this side, and when I was melting, I melted a little bit inside, and the switch didn't close fully, and I had to remelt everything and push it, and yeah, I had to correct one of it, and the other one, then I figured out what to do next. So these are the two switches posts, and this will be glued because it's cardboard on cardboard, and it will be glued like that, and it will stay fixed like that. And this is like a little module, like you see, and it's very, very nice. It's very nice. And also I will write probably there which is on and off, which position, and pretty much, unfortunately, I cannot add LEDs because all this circuit is quite sensitive to even these wires. Probably will eat a little bit of current, and it will disturb my readings that I'm having there. Let's hope not. We will see. We will see. But for now, I wanted to update you about the switches and to show them to you how they are looking when they are not glued, when immediately after I finish them, pretty much. So this switch will interrupt this, and this switch will interrupt this module, and that's the idea. All right, I hope you like it. All right, this is the update, and this is how it looks. Everything is glued on this cardboard, which is a black piece of cardboard, as you can see. It's from a mouse, a computer mouse, wireless optical mouse, crafted for precise, comfortable control. Asus. It's from Asus. Yep. This is the case of that. And it's a cardboard, and everything is glued already. And I also wire it very nicely there. And it's having a common positive line or power supply here that is jumped, that is using a jumper. And this jumper is activating this module or this module or this module. So that's what I'm doing here. If I want all three together, I will add this jumper here, and I will activate this module as well. Or as you can see, this module and this module are activated right now by that. And I'm getting actually a very good reading here, 111. And I should get here one. So this is 111 millivolts, and is set, my DMM, my digital multimeter is set to 2 volts, 2000 millivolts, it says there, or 2 volts. And if I'm activating this, I should get 1.1111, but it doesn't. And you will see in a second. Also, my ampere meter there is showing 111 milliamps, as well as my DMM here, millivolts in this case with my So now if I'm activating this module, is 1.5 of that value almost, and is dropping. And here is, it is showing 1.01. It should have shown 1.03 actually, but it doesn't. They are different, probably a little bit, some difference between these two. But it's doing the job. The problem is this third module, when I'm activating it, is lowering down pretty much the programmed voltage or amperage, whatever, over this 1 ohm resistor. Everything is picked, is good enough. Let me close it off. As you can see, if I'm pushing or dragging from it, it is not getting out from that. Is very well glued there. And also I made these switches. Initially I was thinking to switch from this side, the negative rail, because there are 2 rails, and I was thinking cheaply. But it turns out, after some thinking, it turns out it's better this way that I'm doing it here. And also I'm using these jumpers that I have a ton of them. These little contactors and also jumpers, and yeah. These green ones are actually scrapped, and I have not that many scrapped, but I have a few scrapped jumpers, and I never had any chance to use them. And this is a very good project to use them, to use all these jumpers. As you can see there, it's a bit of a problem setting, resetting and taking them out and putting them in. Well, I will have to deal with it, but this is not a quick experiment. Yeah, these 2 modules are perfect. This is the 1 millivolt step, this is a 10 millivolt step, and this is 100 millivolt step, again over this resistor that I'm taking the measurement. It's the same setup as before, only that now I link them all 3, and this is the complete project almost. I will see if I will add something more than this to it, but I really don't like the error that I'm getting from this module here, and my money, and I bet, is because of the nickel wire, the technology that is used for these resistors, instead of carbon film that is used for the usual resistor, the normal resistor. And I know from a young age, actually, I know this saying that this nickel or wounded resistors usually are bad, but I never knew exactly how or why they are bad. And let me actually show you how bad they are. Right now I will take out every connector here, and I will leave nothing, and I will connect this one, and nothing should happen, and nothing is happening here, and is still reading only this 2. Right now is nothing there. Now when I'm activating the first resistor here, it should be 211. It should keep that 11 there, because all these are full here. And let's see, yeah, you see it dropped down to 0.6 from 11, almost half of it. And now the second is 300. It should have been 11 there, not 0.1. And now it's dropping even more. under the 400. So this should have been 400. This is 500, and even more is dropping, and so on and so on. You see, 78. This is 72, 64. You see how it's getting 10 by 10 down. 64, 55, 44. And this is maintaining somewhere. It didn't drop. It should have been 35. I believe when it's now when it's warming up. Yeah, you see some connection here. Bad connection. Yeah, it is 35 actually. It's a problem. I have no idea where is this dropping down coming from. But let me show you actually. So I'm deactivating this module. I'm taking it out from the circuit, and now let's test this this 1 millivolt thing that I'm having here. I know I should have written here something. And this is a little bit of tolerance there because it's bad programming. This board here is bad programmed. It should have been 100, but it's kind of 01. So now it's 02. So now I'm increasing 1 millivolt up. 102 with a tiny little bit of tolerance, of course. 103, 4, 5, 6, yes, 7, 8, 9, 10, and 11. It's starting from 0 when nothing is on. 0, 1. Yeah, it's doing the same. And now let's do the same thing for this, for the 10 millivolts step. And I will show you they are complying. They are, yeah, you see, it's exactly 10 millivolts here. If I'm taking one out, it's 9 millivolts, 8 millivolts, you see? It's very reliable. It's very well programmed. The code is very well written on this one, on 1 millivolt. 1 millivolt was the easiest to make, actually. So now we should jump with 10. So now we have 20 there. And you see, it's a tiny little bit of tolerance, of course, but is keeping the pace correctly. Now, 30 to the... very good. Actually, I have a little bit of tolerance. If I'm taking out this guy here, I believe I was having a little bit of or not. I was having actually, yes. When I was here, when I was measuring it like that. Yeah, I see 0.6, 0.3, something like that. So right now is only deactivated. This is deactivated. Only this is activated. And I do have a tiny little bit of tolerance. 10.3, but around 4, 3, 4 like that. This is jumping a little bit to 6 here, and here is 7. Okay, let me put it back as it was before and continue with this. Something. Why the fuck are you? Weird shit. And when I was very happy that everything is working as it should be. Shit, fuck. Okay. Maybe something. Not correct. Let me change the jumper. Shit. Shit. Maybe. No. Yeah, well. It was running perfectly. Probably they hit up or I did something. Anyway, let's continue. But it's 30 there. 10 plus 2, 30. Now 40. 41. Let me actually take out one. Maybe like this. Kind of. Nah. Yeah. Okay. 50. Maybe I forgot that one. Who knows? 60. And what 70 and 80, 90, 100, because it's this one also, adding plus 10, and this is 110. And as you can see, and now another plus 1 is 11. As you can see, these two are working absolutely brilliantly, and my money are on this carbon film resistor. It is the technology how they are made, and that's why it's running how this well. And with this ones, my money, my biggest guess is the technology they are made is because the nickel wiring is dropping down, is not maintaining the value of the resistance. Is not maintaining. It is dropping down with the heat. If these resistors were not heat up, if they were remaining cold, they were good enough. They were maintaining the resistive value. They should be at 51 ohms in this case. But as the heating up is occurring in this nickel wire with what they are made of, the resistive value decrease, and is mainly from the temperature rising up. Is my biggest guess, of course. And I am expecting also carbon film resistors and bigger wattage than these are 1 watt, and I'm expecting 5 watts, and they will not heat up at all. I'm expecting not to heat up at all, or maybe tiny little bit. And I will most probably I will take this out and replace it with a new one with those carbon film. So you see, these two are giving me a very good result. The expected result is giving me. And yeah, this is it for this little experiment here. I hope it was conclusive, and we will see next. Now it's very close to being finished at this point, with tiny little bit of adjustments like those resistors there. At this point it's kind of finished, this project, for my intention. And the next phase, and this is opening at the next phase of my project. Actually, while I'm having this completed, I can go on the next phase, and it will be glorious. I really hope so. If all of this is, it will fit my logic, or inverse, the logic will fit with everything I'm building here. It will be very glorious. We will see. We will see. Okay, thank you very much for watching. I hope you like it, and also leave a like, and see you next time. Bye bye.